Okay, so here's the last little bit of this lesson, series and parallel circuits. This right here is kind of a big circuit, okay? And yeah, it looks all confusing and unfriendly, but really, this is not too bad if we take things one step at a time. So here we go. Lamp 1 and 2, this first little bullet point, lamp 1 and 2, shown right here, are connected in series. And the reason we know that is because between lamp 1 and 2, there's only one path for electrons to flow. They can't go anywhere else. All right, so we see this, and we say lamp 1 and 2 are connected in series. Lamp 3, 4, and 5, well, this looks very familiar. Lamp 3, 4, and 5 are, of course, connected in parallel. And that shouldn't be very difficult to recognize. There are, of course, multiple paths for electrons to travel when we talk about 3, 4, and 5. So here we've got 1 and 2 in series, 3, 4, and 5 in parallel. And when we look at this, these two as a chunk and these three as a chunk, relative to lamp 1 and 2, lamp 3, 4, and 5 are connected in this chunk and this chunk between these two parts of the circuit. There's nowhere for the electrons to go. So we say that relative to the first two, the second group of three, these are connected in series. Okay, so that can be a little bit difficult to see. This would be one of the more complex factors that we've talked about so far, but we can still do a lot of these other questions. So, which lamps work when lamp 2 burns out? And of course, if this one goes out, and here's the battery over here, if this one goes out, can current flow at all in this circuit? And the answer is no. So which lamps work when lamp 2 burns out? The answer is none. None of these lamps are going to work if lamp 2 goes out. However, if lamp 5 goes out, which ones work? Well, the only part of the circuit now that's affected, and I'll do it with highlighter, the only part of the circuit that's affected is this part. Everything else, there's still a complete loop. So which lamps work when lamp 5 goes out? Well, 1, 2, 3, and 4. They all still work if lamp 5 goes out. All right, so this is a new concept. A short circuit is defined as a low resistance connection established by accident or intention between 2 points in an electric circuit. The current tends to flow to the area of low resistance, bypassing the rest of the circuit. So there's an expression where we say something takes the path of least resistance. And of course, that's what electrons do. That's what electric current does. Whatever path you give electrons to travel, they're going to take the path that has the least resistance, or the majority of them are going to take the path that has the least resistance. And it's the same with humans as well. If you had two routes to go to school, one was a nice paved sidewalk, and the other was over rocky kind of terrain where you got to do rock climbing and stuff like that. For the most part, on a daily basis, you're going to take the path or the route to school that provides you with the least amount of resistance, either because of time or because of energy or because of complexity. You just take the path of least resistance. Well, electrons do the same thing. So a short circuit exists if we provide, either by accident or on purpose, a path for electrons to travel where they don't have to go through all these lamps. Okay, and so we're going to talk about that in a moment. So most of the resistance is because of the loads, right? So in this circuit, most of the resistance is because of these light bulbs. Now, we know that not all of the resistance is because of those. We know that we lose a little bit of voltage because of wires. But if the loads are bypassed, then the current increases, which leads to a lot of heat, which could produce an electrical fire. Okay, and this happens very, very often in old homes where there's certain wiring. A short circuit is caused in the circuit when lamp 4 is removed and replaced with a copper wire. So if we did this, if lamp 4 was removed, okay, and I'm going to use orange, and if this was just replaced with a copper wire, the question then becomes, so this isn't here anymore, the question then becomes, which lamps work? Well, first of all, does the current have, when we come around here, does the current have any choice but to flow through these two? And of course you say, well, no, because they're connected in series. So we know for sure that lamp 1 and lamp 2 are going to work. And our question then becomes, if lamp 4 is gone now, is lamp 3 and lamp 5 going to work? And so what we've done is we've created a short circuit. We've given the electrons a path to take through this circuit that has very low resistance. So is any current going to flow through 3 or through 5? And the answer is no, it's not. All of the current is going to go through our short circuit, and that's it. So 1 and 2 are the only lamps that are going to work now. And what happens to the brightness of those? Well, now instead of voltage being split between 1, 2, and this whole branch, now the voltage is not split between those two things, and those lights are going to get way brighter. What happens to the brightness of the remaining lights? It increases because it's not sharing as much. The voltage drop across lamp 1 is less than, equal to, or greater than the voltage drop across the battery. Well, we know it's got to be less than, because the battery is providing a certain amount of energy, and that energy is being split up between any number of different things. So the voltage drop is less than, and that's because the voltage is split between lamp 1 and 2, given that that short circuit still exists. And so that's really what question number 4 is all about. It's about short circuit. You'll notice the second part of this note, which I am going to leave for you to do on your own, because we need to get proficient at drawing, is almost the reverse of what we've been doing up here. Here, there is a set of descriptors, and it's going to ask you to draw the battery. So rather than, the circuit. So rather than looking at a circuit and interpreting, this is reading the interpretations and then drawing the circuit. Okay, so this will be a good challenge, but of course the answers are going to be posted on the Google Classroom, so you can check your answers and we can go from there.